almost 10 years, the American manned space program has moved closer to its target of the 1960s with increasingly bolder steps. From the first Mercury flight to the last Apollo mission, the silent secrets of space have slowly given way to persistent scientific investigation and brave men. Apollo 10 was the last of these exploratory flights before man lands on the moon and two of his kind get out of their spacecraft to inspect the lunar surface. Apollo 10 was also the last check on men and equipment. Its overriding purpose, to seek out problems and provide solutions. In this, it accomplished its purpose. At the beginning of the report period, Apollo 10 stood on Pad B of Launch Complex 39. This was the first use of this newly completed launch facility. Preparation went smoothly through the first portion of the quarter, passing the flight readiness test successfully. Near the end of April, the first stage pre-valves were inadvertently opened while the main valves were configured for leak checks. This resulted in dumping almost 5,000 gallons of fuel overboard, creating a partial vacuum in the fuel tank and some dimpling of the upper tank bulkhead. Quick work on the pad by engineers and technicians averted what could have been a serious delay. Careful repressurization of the tank returned it to its original shape. Ultrasonic and dye penetration tests were performed on the outer skin, and a visual inspection was made internally by lowering a man into the tank. No structural damage could be discerned. The countdown demonstration test was then conducted, being completed on the 7th of May. Immediately thereafter, a hydrostatic test was performed, confirming bulkhead integrity. During this same period, Apollo 11 proceeded on schedule in the vehicle assembly building. By the middle of May, the vehicle was fully assembled and ready for its move to Launch Pad A. On the afternoon of 18 May, Apollo 10 began its epic flight to the moon. Its mission, a complete simulation of the lunar mission except for the actual lunar landing and lunar surface activities. At approximately 3 hours into the flight, and at 6,000 nautical miles above the Earth, the transposition and docking maneuver was performed. Although this intricate maneuver went smoothly, a problem did occur that turned out to be more uncomfortable than serious. After docking, the tunnel was pressurized. During this process, the force of air flowing through a small valve in the command module hatch broke the insulation cover on the exterior of the hatch, releasing small particles of fiberglass which filtered into both the command and lunar module cockpits. This method of insulation has been eliminated and will not be a problem on subsequent Apollo flights. At approximately 60 miles above the moon, astronauts Stafford and Cernan in the lunar module prepared to separate from astronaut Young and the command module and begin the maneuver that would take them in 2 orbits around the moon and to within 47,000 feet of its surface. At this point, a far more serious problem occurred. The flight plan called for depressurization of the docking tunnel in order to test the airtight integrity of the command and lunar module hatches and to assure tight seating of the mating surfaces and seals. It was found that depressurization could not be accomplished. Inability to draw a vacuum in the tunnel resulted in an air-bearing effect in the seal between the two vehicles. This in turn caused the lunar module to rotate nearly 3 degrees from its proper position. If the movement had continued to 6 degrees, the mission would have been aborted. After carefully weighing the information, the alternatives, and the hazards, Mission Control and the astronauts decided to proceed as scheduled. At the end of the flight, inspection revealed that a vent plug that should have been drilled with several holes had in fact not been drilled. The circumstances surrounding this omission are still under investigation. Immediately after separation, it was found that the lunar module rendezvous radar was not functioning properly. The difficulty was quickly traced to the command module transponder and a malfunctioning switch. Recycling the switch solved the immediate problem, and the mission continued. The transponder switch has since been redesigned. Lunar photography and television coverage was extensive and outstanding. Topographical and geographical features were closely studied, with particular attention being paid to this area, which is the prime landing site for Apollo 11. At one point, as the lunar module emerged from the backside of the moon, communication between it and the Goldstone tracking station was lost. It has since been determined that the steerable antenna on the lunar module was not tracking at that time. The loss of signal was of short duration, as the command module moved quickly to act as a relay station. Shortly thereafter, the steerable antenna was put back into action. The cause of this malfunction was still under investigation as the report period ended. Another incident, which at this point is not completely understood, occurred when the lunar module separated from its descent stage. At that moment, the module gyrated violently for several seconds. Skillful piloting quickly brought it under control, and rendezvous with the command module was accomplished without further difficulty. As the quarter ended, the cause and the solution of this problem was still under investigation. Although some of the problems encountered during the flight of Apollo 10 were unexpected and serious, the rigid and thorough training of both flight and ground personnel paid invaluable dividends. Reactions were swift and sure, resulting in on-the-spot fixes and successful mission completion. The problems encountered during the flight will be resolved before the lunar landing mission of Apollo 11. The return trip was uneventful and according to plan. And for the first time, our astronauts enjoyed the luxury of a simple, old-fashioned shave before returning to the scrutiny of the world. On the morning of May 26, Apollo 10 announced its return to Earth as a triumphant streak of fire high in the Pacific sky. The precise manner in which this flight was conducted is illustrated by the fact that 4 months ago, the mission planners calculated exactly 8 days and 4 minutes from liftoff to splashdown. Apollo 10 returned a mere 35 seconds earlier than expected. With Apollo's 10th step to the moon successfully completed, the goal established almost a decade ago is within sight. The next step, Apollo 11, if successful, will reach that goal and will also establish America as the first truly spacefaring nation. While Apollo 10 was in lunar orbit, Apollo 11 was moved from the vehicle assembly building to Launch Pad A. All events were proceeding on schedule. While Apollo 11 was being prepared for flight, an important lunar activity was studied and confirmed during this quarter at the Manned Spacecraft Center. Called the Lunar Timeline Studies, it required that Command Pilot Armstrong and Lunar Pilot Aldrin perform all of the activities planned for their 2-hour and 40-minute extravehicular exploration of the moon. After gathering contingency samples, Armstrong unstows a still camera and attaches it to his chest. He is then joined by Aldrin, and together they unstow and assemble a television camera which is placed some distance away and will scan all activities in the experiment zone. A solar wind panel is unfolded and installed nearby where it can be kept under observation by the astronauts and the TV camera. Next comes a period of sample collecting. Both loose material and rocks are procured and put into sample bags. These are packed in the sample return container. Next, the experiment equipment bay is opened. The passive seismic package is removed first. Then the laser ranging retroreflector. This unit is designed to permit precise measurement of the distance between the Earth and the Moon. The passive seismic package is designed to observe and report on lunar seismic activity, meteorite impact and frequency. Solar panels provide daylight power. At night, the unit will be inactive, but sensitive electronic parts will be protected from the lunar cold by radioisotope heaters. Next, another period of sample collecting, including core samples of subsurface material. The last step before embarking will be to hoist the sample return container into the ascent stage. Later in the month, Armstrong and Aldrin were joined by Command Module Pilot Collins in the Gulf near Galveston for a test of antibacteria measures. After righting their spacecraft, a Navy frogman, clothed in a biological isolation garment called Big, opened the hatch and quickly handed 3 more to the astronauts inside. The suits are lightweight material and include a full helmet with plastic visor and a gas mask-like canister to breathe through. Although the possibility of germs or bacteria existing on the moon is remote, it is a possibility that cannot be overlooked, because a microorganism from space could be of such strange and unusual nature that life systems here on Earth might be susceptible. The frogman also carries a spray can of betadine, an antibacteria solution which he sprays on the astronauts, himself, and portions of the spacecraft. After being disinfected, the astronauts are lifted in the usual manner and carried to the recovery aircraft carrier. Another item of equipment directly related to the antibacteria precautions, the mobile quarantine facility, also successfully completed acceptance testing during the quarter. As the astronauts emerge from the helicopter, they will walk through a cloth tunnel and enter the structure. Here they will remain sealed off from the rest of the world, along with an inside staff of 1 doctor and 1 mobile quarantine facility engineer. An outside staff of 10 scientists and technicians will accompany the facility to expedite communications and services. At Honolulu, the quarantine facility and occupants will be airlifted to the Manned Spacecraft Center at Houston and delivered unopened to the Lunar Receiving Laboratory. During the quarter, the launch vehicle stage contractors successfully test-fired 2 first stages, 2 second stages, and 1 third stage. Shipment of stages to Kennedy Space Center is on schedule, with all stages for Apollo 13 now at the launch site. Analysis by Marshall and contractors continued during the quarter into the 16.5 to 19 cycles per second oscillations noticed by the Apollo 8 and 9 flight crews during the latter portion of the second stage burn. Hardware tests, supported by computer simulations, identified the source of the oscillations as a dynamic coupling between the center engine and its supporting crossbeam mount. Further analysis determined that the oscillations could be dampened by earlier shutdown of the second stage engine. Ground tests conducted during the static firing of the second stage for the Saturn 508 verified the feasibility of this approach, which was then successfully used on Apollo 10 and will be incorporated in Apollo 11. At the Marshall Space Flight Center, the Apollo Applications Program continued to move into the hardware manufacture and test phase. At McDonnell Douglas, the Saturn 1B second stage to be used for the orbital workshop was moved from storage and placed in the vehicle and assembly building. During April and May, the J2 engine, aft and forward skirts, and thrust structures were removed and all exterior paint stripped from the stage. Engineering design of all modifications is nearing completion, and fabrication is well underway. Installation of the workshop floor and wall-attached studs has been started. While preparation of flight hardware was underway, at Marshall, preparation for the first major testing of AAP modules started. Early in the quarter, an airlock module test article was delivered to Marshall and placed in the structural test stand. Then the multiple docking adapter test article was placed in the test stand and mated with the airlock module and a portion of the payload shroud. This effort was completed by mid-June. Preparation for the tests, which will simulate launch and orbital docking loads, continued through the balance of the report period. Also at Marshall, another test article was being fabricated and assembled for thermal testing. It is the canister that will carry the experiments of the Apollo telescope mount. After this item is completed, test units of each of the 5 experiments already available will be mounted in the canister. The complete assembly will then be sent to MSC for thermal testing. Near the end of the report period, astronaut Armstrong and backup commander James Lovell, Jr. journeyed to Ellington Air Force Base for a final rehearsal of one of the most critical and delicate maneuvers, the lunar touchdown. The Lunar Landing Training Vehicle, or LLTV, only vaguely resembles the lunar module. However, its flight characteristics have been carefully engineered to duplicate exactly the flight behavior of the LEM. For over an hour, Armstrong put the ungainly craft through its surprisingly graceful maneuvers, hovering, making sideways and rotational adjustments with his thrusters, and finally touching down. In all, 6 simulated lunar landings were made during the test. As the quarter drew to a close, Apollo 11 was on schedule and expected to meet its launch date of July 16th. In summary, the months of April, May, and June were months of continued technological and organizational refinement. The flight of Apollo 10, an outstanding achievement in itself, also demonstrated a more fundamental achievement that will affect America's position in space for generations to come. That is the highly trained, intricate, and interlocking organization of men and women, of NASA centers, manufacturers, universities, launch complexes, and communication systems that is setting the pattern and evolving the routines that will send men farther and farther into space with greater efficiency, economy, and safety.